Hello everybody, today we are starting a new series of videos about electric vehicles, EVs and solar technology. So we're gonna go through a lot of the basic stuff in different kinds of videos and explain about capacity, explain about different kinds of EVs and also how this relates to solar technology, how much energy you can get for solar and what kind of charging you need. We're going to go through all parts of the technology in over many months, because this is an expanding, developing technology that by no means is finished, but I definitely see that as an important aspect of solar and general green energy use. So I think it's important for most members of the group, and I definitely think it's important for solar system owners. So we're gonna definitely follow this area and try to stay updated on what's going on. So let's start with, in this video we're gonna go through the capacity on different solar systems and then take a look at some examples on EVs and how much power we need to put into them from the solar, and see the capacity of the solar system in relation to what kind of EV car that we might have. This is pretty much the first thing we have to do if we are going to determine, number one, if we have a solar system, if that system that we already have is enough for what we need, for the goals that we have, or number two, if we want a solar system for the future to be able to charge EVs, what should the sizing of that be? So here I have listed two of the more normal setups for solar. We have the 5 kilowatt system, and here we have the production. This is just an average. It's going to vary a lot from day to day, but we're going to start with this average. 5 kilowatt, that means the limitation on the inverter. Normally we set more than 5 kilowatt of panels on the roof. That's called oversizing. But in this example, we're gonna start with thinking about 5 kilowatt inverter with 5 kilowatt of panels on top. And that will produce, somewhere around 22 kilowatt hours per day on average. Maybe a little bit less, maybe a little bit more, depending on many factors like weather and stuff like that you can have huge variation. Okay, and then we have another typical system that we also install quite a bit. It is 10 kilowatt. We do the same here. We do not oversize, we stay in the 10 kilowatt panel in that area, and that will produce around this 44 kilowatt hours per day. Now of course we have the normal use that we're going to use a lot of this. How much depends on how much electricity you use and how big a house you have, all these things, how much insulation you have in the house. So the first thing that we need to think about is that if we want to have an EV and charge it with solar power, we obviously have to think about normal use plus EV charging use. And that can be very significant, those two things both separately and together. So if you already have a system that's sized according to your normal load, you will not have enough to charge normal EVs. Let's take an example. MG has a car called MG PHEV. That stands. It means that this car can run on both petrol and you can charge it with electricity. But the battery is quite small. It's 16.6 kilowatt hour. I say small. That's in relationship to other cars, EV cars. So. But you can charge it. This is not a hybrid that you cannot charge, okay? This is a car you can charge from a, a socket basically in your house. And obviously, if you have a socket, that means that if you have a solar system, you will use solar energy to charge this car or any car. So that's how it works. And then 16.6, that's the number that's of importance here. And then we can compare that with 22 for the 5 kilowatt. So then we see that if we have a 5 kilowatt system, we are actually using almost all our capacity every day if we are charging this once a day. Doesn't have to be like that, of course, but it can be like that. So you just have to analyze your own need and use. That's kind of hard to know if you have never used an EV. But for some people, it's definitely going to be relevant to charge this every day, absolutely. So we're just going to use that as an example in this video. Can do other examples later. So you want to charge this every day, you want to use 16.6 kilowatt hours every day, and you want to take the majority of it from the solar system. Which means that you have barely anything left over for your load in the house. That might be what you have planned, but in normal cases, it's not what you have planned. That means that you don't have any power left to put on the house. So in that case, you need more solar, basically. But if you use very little electricity, obviously some people do that, and then you had that planned from the beginning, that maybe you use very little electricity in daytime, and then you have actually available 16, 17 kilowatt hours, then yes, then you can actually do it and use solar power. But it's going to use a lot of the day to do it, because obviously a 5 kilowatt hour a 5 kilowatt system cannot put 20 kilowatt in terms of time very fast into the car. That's not possible, because it's only producing direct power of around, between 3,000 and 4,000 watts in the middle of the day. So that means the car has to be connected all day, almost, because that's what it takes. That's the time it takes to get 16, 17 kilowatt hours into the car, because the solar system is not producing more throughout the whole day. So you see, the solar system also has a determining factor in regards to how fast you can charge your car. If the solar system doesn't provide more than, around 20 kilowatt hours in the whole day, it's completely impossible for it to charge it very fast, because it's taking the whole day to produce it. So if we compare them, just to talk a little bit more about the speed, is that if you have a 10 kilowatt, at least then you have the possibility of charging double fast in terms of capacity in the solar system. Now there could be other limiting factors too that we will get into later in other videos, but this is certainly one limiting factor that we have to consider first. The mere size of the system, how that determines how much you can charge throughout one day. Okay, so the MG car that we used in this example, it has a small battery. Now let's take another example and look at another car that has a much bigger battery. And EVs are coming with much bigger batteries all the time, so this is not abnormal at all. We're looking at the BMW iX3, and this car has an 80 kilowatt hour. So you think that's a lot? Actually, it's not a lot. If you think about the new Volvo XC40, that's a full EV car. It has, I think, 100 kilowatt hours, something like that. I'm not 100% sure, but it's in the same range. And there are EVs that come with actually much more. The point is that EVs will come with 80 and above, and sometimes a lot more. So it's not abnormal at all. So we see here that even with a 10 kilowatt system, solar system, you will not, even if you use the solar system only to charge this car, it will only charge half of the battery size. So that just tells you how much power is needed to fill up the batteries. That's number one. If you don't use the solar system to do it, it also tells you how much you're going to have to pay in electricity bill if you fill this car up a lot from the grid. It's going to be very, very expensive. You know, everybody knows the kilowatt hour price in Thailand. That's about 4.2 for residentials. So you just take 80 times 4.2 and then you know the price for every full tank, so to speak, of electricity. So then it also becomes very evident that some people need very big solar systems to be able to charge the new EVs. And I hope this video gave you a little bit of a starting point to start thinking about how we can use solar technology and sizing and everything. And obviously, how you should plan and oversize your solar systems by a lot if you are planning to do EVs. Okay, guys, I don't want to make these videos too long. I mean, there's a lot of things we have to go through, so I'll stop there and we'll move on and we'll continue with this series as time goes by. Okay, guys, good luck.